If you've been watching the AI space explode lately, with things like ChatGPT just completely changing the game, you've probably wondered, what's really going on under the hood? Well, today, we are pulling back the curtain on the one piece of tech that's made almost all of it possible. So what is it? What's the secret ingredient that took AI from this kind of niche academic thing to a force that is reshaping our world? And seemingly, it all happened overnight. The answer is a concept called the transformer. It's a type of deep neural network, and it is the foundational architecture for basically every major AI model you hear about. It didn't just make AI a little bit better, it rewrote the entire playbook. Okay, so let's get into it. The amazing thing here is that the transformer didn't, slowly evolve over decades of research. Nope. It basically sprang into existence from one single, incredibly important research paper. And this is it. A paper that came out in 2017 from a team at Google, and it had this just killer title. Attention is all you need. Not only did this paper introduce the transformer itself, but that title, well, it gives us a massive clue about what makes it so special.
And if you want to understand the impact, just look at this number. In the few short years since it was published, this one paper has been cited by other academic papers over 100,000 times. I mean, in the world of research, that is unheard of. It's a signal that this wasn't just another idea, it was the bedrock for a whole new era of AI.
So, how does this thing actually work? Well, what's kind of funny is that the original paper wasn't even trying to build a chatbot. Its goal was way more specific. It wanted to get a machine to translate language. So, let's use their original example, going from English to German, to break it all down.
At a high level, the process has a few key parts. You start with your text, right? First, that text gets chopped up into smaller pieces. Then, a component called an encoder basically reads all those pieces to figure out their meaning and context. And finally, a decoder takes that understanding and uses it to write new text one word at a time. So let's zoom in on these steps. First up, we have tokenization. You see, an AI doesn't read a sentence the way you and I do. It has to break it down into these little units called tokens. Each token then gets its own unique number, its own ID. This is the very first step in turning human language into something a machine can actually work with. Now this is where it starts to get really clever. The encoder takes those simple number IDs and turns each one into what's called a vector embedding. Now the best way to think about this is like giving every single word a rich, detailed set of GPS coordinates. These coordinates don't just identify the word, they place it on this huge, complex map of meaning. It captures what the word is all about and how it relates to everything else.
And what's so cool is how this map of meaning organizes itself. As you can see here, words with similar ideas, they all get grouped together in this vector space. So words like king, man, and woman all cluster together in a neighborhood about people and royalty. Apple, banana, orange, they're all hanging out in the fruit section. It's this mathematical closeness that lets the model learn relationships. It knows apple is way closer to banana than it is to football. But look, just understanding what individual words mean isn't enough to understand language. The real magic, the true breakthrough of the transformer, is in understanding how all the words in a sentence relate to each other. And this brings us back to that idea from the paper's title, attention. Let's take a look at this sentence. This is a classic example of a problem that used to just stump older AI models. You have your subject, the dog. Then you have this long phrase in the middle. And way at the end, you have the pronoun, its. For us, it's a no-brainer. Of course, its refers to the dog. But for a machine, the word squirrels is actually much closer. So how does it make that connection across the entire sentence? This problem is called a long-range dependency, and for years, it was a massive roadblock for AI. And the transformer's solution, the mechanism that cracked this problem wide open, is something brilliant called self-attention. This right here. This is the secret sauce. Self-attention basically lets the model, when it's looking at one word like its, to look back at every other single word in the sentence and calculate an attention score. It figures out how relevant every other word is. It learns that dog is super important for understanding its, while words like squirrels or afternoon, not so much. It allows it to connect words no matter how far apart they are. It's a total game changer. So this incredibly powerful idea didn't just stay in one form. It quickly evolved and gave birth to this whole family of models, including two names you've almost definitely heard of, BERT and GPT. A simple way to think about them is like this. BERT is the reader. It only uses the encoder part of the transformer. It looks at text in both directions, left and right, and it's amazing at asks that require deep context, like filling in a blank word in a sentence. On the other hand,
GPT is the writer. It's decoder only, it reads text from left to right, and it excels at its most famous job, predicting the very next word, which lets it generate flowing, coherent text. Now, this brings up something that can be a little confusing. We hear the terms transformer and large language model, or LLM, thrown around a lot, sometimes as if they mean the same thing. They're related for sure, but they're not identical. So let's do a little myth busting. Myth number 1. Are transformers only for language? And the answer to that is a hard no. It turns out you can apply the exact same core idea of attention to the pixels in an image instead of the words in a sentence. These are called vision transformers, and they are incredibly good at things like image classification.
Now, what about the other way around? Are all large language models built using transformers? Also no. Before that 2017 paper, models were based on totally different architectures, like recurrent neural networks. Now, it's true that today, almost all of the modern, state-of-the-art LLMs are built on the transformer architecture, but the two terms aren't technically the same thing.
So in the end, the transformer, all powered by this core idea of self-attention, represents a true seismic shift in technology. By finally cracking the code on context, it unlocked all the incredible AI potential we're seeing today. And the craziest part? It all happened in just a handful of years. Which, of course, leaves us with one massive question. What's going to be the next attention is all you need moment?